Okay, so the production function, according to figure 3.1, we don't really need to review. Yeah, so there's so much later that's way more important, but they don't write it this way. This is just the firm, and these are the inputs, these are the outputs, things like that. So that is figure 3.1 right there. The production function, according to figure 3.1, the firm uses inputs and produces outputs. Inputs, also called factors of production, can take many different forms, such as machines, labor, land, and raw materials. Inputs might be further detailed, for instance, low-skilled labor, high-skilled labor, lumber, cotton, etc. To simplify our analysis, we will mostly consider two inputs. We will use L. We started with this in the last video. So we will use L to represent human input labor and K to represent non-human input capital. Output is whatever good or service the firm produces for the market. A farm can produce strawberries, a factory can produce nails, and a school can produce educational services. Something the firm can produce sometimes. The firm can produce different outputs. At the same time, a farm might be able to produce both strawberries and blueberries. To simplify our analysis, we will mostly consider a single output represented by Q. So the firm uses L and K to produce Q, the production function. We're starting to get into the math finally. But the firm uses L and K, that's labor and capital, to produce Q, quantity Q. The production function is a mapping which assigns to each input usage LK one maximum technically possible output Q. We write the production function as, so they always say the easiest thing. A mapping is just another definition of a function, or a way to describe it, we should say. But you have inputs, independent variables, L and K, a multi-variable function, and then an output Q, which maybe we want to maximize or something, not necessarily. But it is best to think of each of these variables as flow variables per unit time. We could, for example, measure labor as the number of hours worked per person per day, summed up for each type to labor. Capital would be measured similarly in that we would take a machine, we would take machines times the number of hours used per day. Output would be output per day in this specific example. The time period can be any finite time period so long as the period of input, use, and output production are the same. Yeah, the time period can be any finite time period so long as the period of input, use, and output production are the same. So the important points are that this is a one period or one static model. Yeah, this is a one period or a static model that we must be consistent in measurement across all variables, as in the example above. Yeah, in some instances, we will consider one unit of labor L to be one full day of work, 8 hours worked, and one unit of capital K to be 8 hours of capital used. Yes, so there is that important point. We spend a lot to say that it's not so much important in this chapter, but L is some quantity of labor, and perhaps a quantity is a function of time, and K is some quantity of capital. K is a quantity of capital, also as a function of time, but we always do it where the time periods are equal, so we don't really consider that. We just want to consider some simplified unit of labor and some simplified unit of capital. So in some instances, we will consider one unit of labor L to be one full day of work, 8 hours, and one unit of capital K to be 8 hours of capital used. In these cases, we can simply refer to L as the number of workers hired by the firm, and K as an amount of capital used by the firm, where one worker represents one full day, 8 hours of labor hours worked, and one unit of capital represent 8 hours of capital is used. Which unit of measure, hour, day, week, etc., is more convenient to use depends on the example we want to study. Yeah, so very wordy, but they're trying to simplify it. So we are taking the production function f as given, and we are treating it as a black box. Right now, we are not concerned about how the firm transforms inputs and outputs. We are simply assuming that the firm has some knowledge of how to do it, and it is doing its best to produce as much output Q as possible, given a particular amount of inputs L and K. If your field of study is operations research, logistics, or the engineering of production, then part of your specific job is to open this black box and try to produce efficiently. Similarly, an important part of the production technology is how to organize and manage the workforce. Hence, part of your job as a manager is to exactly try to improve the production function. We will talk more about this point later when we study incentives for workers. For now, just to manage that the firm has some knowledge regarding how to best run the production, and suppose that F summarizes this knowledge, the function that the quantity function that we were just talking about. So, for example, consider a factory that uses labor L and capital K to produce a quantity of nails Q. The firm cannot produce nails by using labor only or capital only. The firm needs to use at least some workers and some capitals. Moreover, if the amount of capital is fixed, it becomes harder to produce more by just adding workers. Similarly, if we fix the amount of labor, it becomes harder to produce more by just adding more capital. After observing how much the firm can produce when using different amounts of labor and capital, suppose the researcher concludes that the firm's technology can be represented by the Cobb-Douglas production function. So now we see where chapter 2 was leading. We have linear and all that, but the Cobb-Douglas, I think, is by far the most important in the book. So after observing how much the firm can produce when using different amounts of labor and capital, suppose the researcher concludes that the firm's technology can be represented by the Cobb-Douglas production function. And there we have it there. Um, we could predict this exercise. We could replicate this exercise in other firms, observing their characteristics to find a production function that matches their technology. So what is a production function after chapter 2? The Cobb-Douglas, of course, is a example of the production function and probably the most important. So we're just kind of doing a video per section. They kind of introduce, we're just introducing the ideas, basically. L and K, I don't need to say it a bunch of times, but L and K are just simplified quantities that do mean something conceptually, but we kind of lose track of exactly what they mean. 3.3.1, this will be for a different video here.